we turn our attention from land to the sea. With more than 90,000 ships making up the world's commercial fleet, carbon emissions from shipping alone account for approximately 3% of the world's CO2. Modernizing one of the world's oldest forms of trade with cutting-edge, clean energy technology is no small task, but that is exactly what Bloom has set out to do. Bloom Energy's fuel cell technology has excelled at powering massive loads like stadiums, manufacturers, and other large facilities on land. It makes sense that the same technology would be equally effective at sea. In 2020, Bloom and Samsung Heavy Industries announced plans to design and develop fuel cell-powered ships to realize a shared vision of clean power for the maritime industry. Since that time, we have received verification as an alternative power source for vessels as part of the American Bureau of Shipping's new technology qualification service, signaling the readiness of our fuel cells to withstand the harsh conditions at sea. And working with Chantier de l'Antique and MSC, together we launched the world's first cruise ship operating on solid oxide fuel cell technology. The future is bright as we accelerate the marine industry toward a more sustainable future. Now let's check back in with Scott to learn more about Bloom's efforts to aid marine decarbonization. Take it away, Scott.
So Justin, we're here to talk about marine. One of the really cool things that we're going to do is show you some of the testing we're doing right now to make these systems capable of running at sea. So we've got a visual for you that I think is pretty neat, which is a tilt table running here in the background, which describes some of the functionality we've used to make this capable of running at sea. And I'm joined here today by one of my longtime colleagues, Suminder Singh. Suminder, how long have you been at Bloom Energy?
A little bit more than 9 years. 9 years and 3 months to
So why don't you quickly explain what's going on here with this device in the background?
Yeah, so my name is Suminder. I'm responsible for bringing Bloom's core platform to the marine world. As you can imagine, running the fuel cell on the land is slightly different than running the system on the ocean. So what we have over here is a tilt platform that replicates the environment that our system is likely to see on a ship when it's sailing on the ocean. So for the last 6 months, we have been running our hardened marinized fuel cell on the tilt table, tilting at 22.5 degrees constantaneously.
So how are customers reacting to seeing the capability of being able to run at sea, Suminder?
As you know, International Marine Organization has some very aggressive standards when it comes to reducing the carbon footprint. The 2030 goal is reducing the carbon intensity by 40%, and by 2050, the goal is to reach 75% carbon reduction. However, there are certain marine customers that are moving much more rapidly. An example of that is Chantier de l'Antique, which is a major shipyard that builds cruise ships. They approached us last year, towards the middle of last year, to deploy a fuel cell system on one of the ships that is going to sail later this year. So we have made tremendous progress in designing the system, testing the system, and all the units have been shipped to France. And the most exciting opportunity is what we have been hearing is there are 100 cruise ships that are in the sales funnel for all the shipyards. That equates to about 4 gigawatt worth of power generation. That is the most exciting opportunity.
So huge opportunity in marine. We're doing the testing as we speak. Justin, back to you.
Thank you, Scott and Suminder. I'm a little seasick from all the movement on the ship there. While it's not easy to ready new technologies for marine deployment, Bloom is well on its way to decarbonizing a centuries-old maritime industry. Scott is going to continue his journey through our Research and Technical Center, making his way next to our hydrogen area.